Okay, let's do number 62 together. Darling Darlis wants to cross the Grand Canyon of the Snake River by being shot through a cannon. She wishes to be launched at 60 degrees relative to the horizontal so she can spend more time in the air waving to the crowd. With what speed must she be launched across the 520-meter gap? First thing we'll do is we'll draw a picture. So we've got a gap here which is 520 meters. She's going to go up at 60 degrees and then come back down. Let's assume that that's kind of even there. 60 degrees. So she goes up, she comes back down at the same elevation. So we need to know what speed she needs to be launched at. So the first thing we'll do is let's look at the equations for the velocity in the y direction and the velocity in the x direction. The velocity in the x direction, that's straight ahead, is going to be equal to our initial velocity, the one we're trying to solve for, and that's going to be times the cosine of 60 degrees. The velocity in the y direction is going to be equal to the initial velocity times the sine of 60 degrees. So that gives us our initial Vx and Vy. Let's also take a look and see what we can solve for quickly. We know that the amount of time that she takes to get across the canyon is going to be equal to her velocity in the x direction divided by the distance that she has to go. Because we have this really basic equation that says that distance is equal to velocity times time. So we can say that time is equal to distance divided by velocity, and that's the x velocity. So let's go on and substitute that in with this equation right here, and we'll say that the time it takes to go the entire distance is equal to 520 meters divided by v naught times the cosine of 60 degrees. So that's the time it will take her, Darling Darlis, to go all the way across the canyon. We also have this equation which says V final is equal to V naught plus AT. Now, A is acceleration due to gravity pointing down, so I'm going to change this to minus GT. And I can use this equation to figure out how much time it'll take to get to the top of the parabola that she is describing as she's shot out of the cannon. That's going to be half of this time. That's going to be half of this time. So I can say that her final velocity at the top of the arc is equal to her initial velocity minus g times half of this time, which is 1/2 of 520 meters divided by v naught cosine 60 degrees. Well, this final velocity we know is going to be 0 at the top of that arc, and v naught here is actually the vy naught, so I can substitute in my vy here. So I'm going to say v naught sine 60 degrees. I'm running out of room. And here we have the equation that we can now solve for v naught. I'm going to take this and put them on opposite sides because there's subtraction there. So we say v naught sine 60 degrees is equal to g times 520 meters divided by 2 v naught cosine 60 degrees. I'm going to solve for v naught. So to do that, I'm going to multiply both sides by v naught. So I get v naught squared, and I'm going to divide by sine 60 degrees. So I end up with 520g divided by 2 sine 60 degrees cosine 60 degrees. And there's a trigonometric identity that I can use to do this, but I'm not even going to waste time. It's the same one we used when we did the range equation. Instead, I'm just going to solve this directly. So 520 times, and for g, I'm going to use 9.8 just because, meters per second squared, and this is meters. So 9.8, now I'm going to divide by 2, divided by the sine of 60 degrees and divide it by the cosine of 60 degrees. And I get V naught squared is 5884, and this is meters squared per second squared, because meters per second squared times meters is meters squared per second squared. So I can take the square root, and V naught is equal to the square root of 5884 meters squared per second squared. And so my answer is 76.7 meters per second. So Darling Darless needs to be shot out of the cannon at 76.7 meters per second in order to make it to the other side. Hopefully a little faster, because if she's waving to the crowd, that's going to slow her down and she'll crash into the canyon. But in a vacuum, no air resistance, that'll get her to the other side.